A new artificial intelligence AI method has been used to identify an asteroid that could one day present a threat to Earth. Scientists made the discovery using a computer processing method called an algorithm. The algorithm searches through data collected by 4 different Earth-based telescopes. The goal is to identify asteroids that might present a risk of crashing into Earth. The asteroid search effort is financed by the American Space Agency, NASA. It is operated by a team at the University of Hawaii's Institute for Astronomy. The system is called ATLAS. It involves 4 different telescopes. 2 of the telescopes are based in Hawaii. Another operates in Chile, and the other sits in South Africa. ATLAS is designed to search the whole sky several times each night, looking for moving objects, NASA explains. NASA and its international partners continuously search the skies for what scientists call near-Earth objects, or NEOs. Such objects include asteroids and comets that come within 50 million kilometers of Earth's orbit. The effort aims to identify and follow NEOs that could one day strike Earth. NASA says a large majority of the NEOs that enter Earth's atmosphere burn up before reaching the planet's surface. But the space agency is concerned about larger NEOs up to 50 meters in size. NASA says such objects could cause widespread damage to areas they hit. The space agency considers NEOs that come within 7.5 million kilometers of Earth's orbit and that are bigger than 140 meters potentially hazardous objects. Researchers from the University of Washington created the algorithm and led the latest discovery operation. The team announced in a statement it had identified a 182-meter-long asteroid named 2022 SF289. The find came during testing of the new algorithm, which the researchers called HelioLink 3D. The researchers said the newly discovered asteroid met the description of a potentially hazardous asteroid, or PHA. However, the scientists said asteroid 2022 SF289 will likely present no threat to Earth in the foreseeable future. The newly discovered asteroid was the first PHA to be identified with the HelioLink 3D algorithm. Scientists plan to use the new algorithm together with the Vera C. Rubin Observatory, which is still being developed on top of a mountain in Chile. Rubin is expected to start operating in early 2025. University of Washington researchers have said the observatory should greatly improve the discovery rate of PHAs. This is because the telescope was built with a very powerful new camera and a huge mirror. Some NEOs are difficult to identify with existing telescopes because they can be blocked by bright areas of space. For example, other equipment missed asteroid 2022 SF289 because of rich star fields that exist in our Milky Way galaxy. Rubin's instruments are expected to provide more detailed images and data to improve the identification process for NEOs. Ari Heinze is a researcher at the University of Washington and a main developer of the HelioLink 3D algorithm. He said in a statement, "By demonstrating the real-world effectiveness of the software that Rubin will use to look for thousands of yet unknown, potentially hazardous asteroids, the discovery of 2022 SF289 makes us all safer." The University of Washington researchers say more than 2,350 have so far been discovered. They say with the new algorithm, scientists hope to identify thousands more. Astronomers using ATLAS say discoveries of PHAs are made when they identify a point of light moving unambiguously in a straight line over the image series. The HelioLink 3D algorithm was developed specifically to be used by the Vera C. Rubin Observatory. But Heinze and other researchers said they wanted to see if it could discover a new asteroid using existing telescope data. After Rubin's team set HelioLink 3D to search through Rubin data, it identified its first PHA on July 18th. The asteroid was 20 million kilometers from Earth. Atlas astronomer Larry Denau was a leader of the discovery team. He said the algorithm shows it is possible to recover these faint objects as long as they are visible over several nights. Denau added, "This in effect gives us a bigger, better telescope." I'm Brian Lynn.